Okay, we're going to go through all the different kind of conditional statements there are and what they look like. And this, since this is a foldable, it's going to be kind of messy because you're going to have your inside part. It's going to look different than mine. So basically what I'm going to do is I'm going to write a little bit on the outside part with the words, and then I'm going to add the examples in the middle. So we're just going to see what it looks like, I guess. Okay, the hypothesis and the conclusion is it's an if-then statement. So the hypothesis is the if part, and the conclusion is the then part. So I'm going to put those kind of in quotes. Okay, so we use the letters P and Q. We use the hypothesis as the letter P, and the conclusion is the letter Q. And so if we're gonna use an if-then statement, we say if P, then Q. An example might be, if I'm tired, then I'll take a nap. So my hypothesis is when I'm tired, if I'm tired, and then what happens if that's true is that I will go take a nap. So that also kind of is part of this, what we call the conditional statement. So basically I just told you what goes on here. So the whole conditional statement is the if-then. Hypothesis is the first part, conclusion is the second part. This is when you put them together. The hypothesis and the conclusion. That's your conditional statement. So it's a statement in the form if then. And the way we write it, instead of writing if P then Q, we've shortened it to just P, Q. So instead of writing if P then Q, we just write P to Q. Okay, so that is our shorthand for if P then Q. Secret code, always like to have some. All right, so now when we get to the next ones, we're basically taking the conditional statement we have and we are changing it and then deciding if that's going to be true or not. So for converse, what we do is we switch the hypothesis and the conclusion. And we're going to put some examples inside the foldable, which I guess I could go down and do, okay. So if a conditional statement is P then Q, then if we switch them, we're going to have Q first and P second, okay? So notice that these guys switch around. Okay. I guess I'm trying to think what's easiest to do. Let's go down to the bottom, and like example number 3 goes with conditional. So basically, this is your conditional that we're going to do an example. So if you open up your Foldable, this should be underneath conditional. And we have that sentence, but there's no if then. So we're going to rewrite it. If two angles are complementary, then they are acute. So there's our if then that goes with our conditional statement. So a lot of times you're going to see a conditional statement, but it's not going to look like one. And so we're going to change it so that it looks like one. So on the back of the word conditional, we have our picture right here. Okay. Birds is the whole big circle, and blue jays are birds. So they're a small subset of birds. So the way we would write this is if it, whatever it is a blue jay, then it is a bird. So if it fits in the blue jay category, then it fits in the bird category. Okay, so that's conditional. So now let's do converse, which again, this is what we said up here. We're switching the hypothesis and the conclusion. So example 5, I guess we could do example 4. It's weird the way this is done. Okay. Let's make this, so if a person owns a dog, then they are a pet owner. So we're going to basically switch these two parts. So I'm going to put this first and the other part second. So if I was going to rewrite that, I would write if, not that one, if a person is a pet owner, then they own a dog. Okay, so the first one was true. If you own a dog, you are a pet owner. The second one is false, and you can think about why it's false, because you don't have to own a dog to be a pet owner. You could own a cat, you could own a bird, you could own a snake, and you would still be a pet owner. So when we find the converse, it's false. Sometimes it's true, sometimes it's false. Okay, so let's look at example 5. If angle A is a right angle, then angle A measures 90 degrees. So if we're going to turn it around, if the measure of angle A is 90 degrees, then angle A is a right angle. And that is true. So they're both true. It's true frontwards and it's true backwards. So, give you a little hint. When we get to biconditional, this one's going to work for biconditional. So we'll remember that, and then we'll come back to it. Okay, so now I've caught up my inside with my outside. All right, so let's go back up to the front and talk about inverse. Okay, inverse is the negative. So we're negating is the word. making negative or opposite, because it's not necessarily like negative, kind of more like the opposites of hot and cold versus negatives of like a negative number and a positive number. So we keep it in the same order. Okay, we just use a big ol' N in front of it. I feel like we use a different symbol somewhere else, but okay. So if I start out with if P then Q, my negative is going to be if not P, then not Q. So I'm changing it from positive to negative, or opposite. Okay, so let's go down to our example 6. And let's write the inverse. Okay, so let's find example 7 in a minute. So I'm keeping my class first and math second. But I'm going to put if you are not in my class, then you are not learning about math. Now, I certainly hope there are other classes that teach you about math. So while it's true that if you're in my class, you're learning about math, if you are not in my class, are you not learning about math? I'm going to say it's false because you might be in physics. You might be in business math. You might be in... That's all I can think of off the top of my head. But it's possible that you're not in my class and you're still learning about math. You could be in tutoring. Okay, so that's what negating means, is we put the word not in, basically. All right, where's example 7? Is it up here? Inverse counterexample. Oh, I got it. We're thinking of some counterexamples to if you are not in my class, you are not learning about math. So one counterexample could be maybe you're in a different math class. Maybe you're in Mr. Tebow's math class. Then you would be learning math. So a counterexample proves it false. So one we could write for if I'm not in Ms. Nagel-Perkins' class, I'm not learning math. Well, I could be in Mr. Tebow's class. I'm learning math, so that proves that my inverse is false. Another one might be, we just said, I'm in physics. I'm learning math. Also a counterexample. Okay. Hope that makes sense. So we'll come back and do those other counterexamples in a minute. Okay. So contrapositive is like a double switch. Contrapositive is converse and inverse. So you switch, I'm going to change colors. So you switch P and Q and make it negative. So a contrapositive would be not Q, then not P. Okay, so let's go down to example 8. Okay, so the conditional would be if it is Monday, we're doing this right here. If it is Monday, we wear pink. Then we wear pink. So contrapositive, I'm going to switch it around and make it negative. So my contrapositive would be if we are not wearing pink, then it is not Monday, which is probably true. That's probably a pretty good one. Because if we're not wearing pink, it's not Monday. Because if it is Monday, then we're wearing pink. So we could talk about it as the inverse and the converse, but I think we'll just leave it at that for now. Okay. One more is biconditional. So biconditional is when the conditional and converse are true. Remember we wrote that up there a minute ago. So if and we write it like this. P, if and only if. Q. And even shorter, we write P, I, F, F, Q. So that stands for if and only if. Yeah, okay. Or you could put a P and a Q with double arrows, showing that it goes both ways. So you could use this one or this one, both correct. Okay, so let's go back up to the one where I wrote biconditional. Where'd it go? Oh, it wasn't up here, it was down here. Aha, okay. So look at this one. So because angle A is 90, it's a right angle. If it's a right angle, then it's 90. So we could write that as an if and only if statement. We could say measure angle A is 90 if and only if the angle is a right angle. So another example would be if a triangle, we haven't really talked about this yet, but if a triangle is obtuse, then it has exactly one obtuse angle. That's true. Okay. So does that mean if a triangle has one obtuse angle, it's an obtuse triangle? Yes. So we're going to write it a little bit different because it's an if and only if. So I'm going to write a triangle has exactly one obtuse angle if and only if the triangle is obtuse. Okay, so let's think about the next one, see if it's true also. If two angles are supplementary, we've been talking about this, then they are both obtuse. Well, first of all, if they're supplementary, if two angles are supplementary, they're both obtuse. That doesn't work anyway, because supplementary means 180. Obtuse means more than 90. So they could both be 90, but they can't both be more than 90. So one of them could be. So we're not going to even do that, okay? So a counter example would be, and I'm going to draw a picture, because I can. If this angle is obtuse, then this angle is acute. So I have obtuse, acute, counter example. Even if I got to the smallest obtuse angle I could make, right? This would have to be 91. Then this one would be 89. It's still the same thing. This one's still acute. So it doesn't work. All right, let's finish up with the stuff on the back. Okay, we're looking for counterexamples. So first of all, if a person owns a dog, they are a pet owner. That is true. Look at the next one. If two lines intersect, they are perpendicular. So we could draw like that and go, oh, those are perpendicular. But do they have to be? They could be. But what if I drew my lines like this? They still intersect. So they're intersecting. Not perpendicular. Okay, so this would be my example. This would be my counterexample. Alrighty, there you go.